oscillator design called the Piston Honda. It's based on half of the Hertz donut core, and it's a wavetable design using 8-bit wavetables. I have it on channel 1 here. Okay, for this demonstration, I have the wavetables are organized into 16 banks of 16 waves, so it helps to imagine them as a square. And each dimension of that square can be modulated, and the waveforms can smoothly interpolate. And there's also a discontinuity control on here, which adjusts how smooth that interpolation is. Yeah, they're just fading from wave to wave. And it ships with 512 waves organized into 2 ROMs, full of 256 each. The one we're listening to right now is the A ROM. It's kind of choppy and noisy, as you've heard. It's my favorite kind of wave. The B ROM is full of additive stuff. Yeah, there's an expander for it that's a little PCB about the size of a stick of gum. It has 6 slots on the back, which accept serial EEPROMs. If you got the hardware to burn onto those, that's great, but otherwise I offer a service for it. The waves can be written by a Wired Synthesizer's Wave 256 program. And I'll demonstrate, this one has an expander installed, so I can show you the 2 waves that ship with it. To activate the expander, you hold down that ROM select button, wait for the displays to change. Actually, I better pull those out now. And then dial in the ROMs that you want. Okay, let's take a listen. Okay, that's Matthew Davidson's Bosch Gardens waveform ROM, which was previously available for the Blasted Mini Wave in Wired Waveform City. Now this one here is those waveforms were inspired by the PPG Wave and the Sequential Prophet VS. Those are some really nice waveforms. I'm going to take a minute to talk about the Joystick module that I've been using to modulate the wavetables here. It's created by my friend Flight of Harmony, and I think it's a really awesome performance module. Not only does the joystick action feel really nice, it's got a proper amount of resistance, 2 gate buttons, and offset and scale controls. He's also solved the problem of control orientation by making the entire module reversible. All the words are right side up and upside down, and you can read it whatever way you want, and I keep mine mounted upside down so the joystick's on the bottom. And it's also really inexpensive, and it does everything it says on the panel. Let's move on to the next module. This is the Time Safari. It's a 8-bit sampler that I designed that was, I was thinking a lot about the old Casio SK1 when I did it. I laid out the memory bus the same. It's basically an 8-bit audio buffer where you can record a second and a half of audio into it, and then chop it up, loop it, manipulate it. It's got a feedback loop on there, so you can start layering stuff. This is what I got in there right now. Let's turn the looping on. So you can do stuff like that. You can reverse it. The loop points also have control voltage inputs as well. So you could, put the joystick on them, or your force sensitive resistor controller. Now, we'll come back to the Time Safari in just a second, but I'll now demonstrate another module called the Zoran Cannon. It's a dual function module where the bottom half makes pitch noise outputs like the Atari 2600 and 5200 sound chips. Each output has a mode switch for different types of sounds. I'm sure some of those sounds are kind of familiar to some of you. Frequency modulation input on this is linear, kind of like the Hertz donut, so you can get some nice stuff out of that. The top half of the Zoran Cannon works on the same principle as audio generator. That's a bunch of linear feedback shift registers for generating pseudo-random pulse trains. But here they're not running at an audio rate. You can see what they're doing with these four LEDs, yellow LEDs. They're generating gate signals that can be used to trigger things. So what we're going to do is all the transport controls such as direction, loop, play, record on the Time Safari are also supporting gate inputs. So first of all, let's start playing an MP3 into that Time Safari. And then we're going to start automatically recording and looping it by using these gate signals. So, get this. Turn the Time Safari back on.